Okay, welcome everybody to Drake's Lounge, September. So far, still looks like Owen's Valley's a go for the Western Conference. We still got to get all the details mapped out, and then we'll get some dates and some ideas on travel arrangements and housing to you guys. Hopefully by this next journal, we'll have all that in the next journal, and then we'll present that. I've been in contact with the University of Zambia through our esteemed Vice President, Marcus Fisher, who hooked us up, and they are very interested in making a Drake's Lounge Africa. And we don't have times or dates yet, but it's just going to be modeled after what we did with Drake's Lounge Australia, which really drew all of the Australia amateur radio astronomers together. There's those groups who were not talking together before Drake's Lounge Australia. Now they're all talking together. They're very interested in doing this. We got a little huge radio astronomy community in Africa, and the University of Zambia wants to maybe pick up the banner of helping Sarah get that going. We're off and running on that. We may have a couple representatives from them showing up on the Drake's Lounge. So we'll see if they make it. And I was just telling from a personal note, personal exploration note on radio astronomy, there's two things I've been doing using Ted's Easy RA. I do have a 3-meter dish in my backyard, and I've been taking observations with that, and I've got about five runs so far at different elevations. Then I tried, Jason, you'll be happy with me on this, is that I tried to use it for M33 observation. And by doing that, Ted had to go dig up the way to change the base frequency and the reference frequency to get the higher Doppler, because M33 is closing on us, and I had to get at 1421 megahertz instead of 1420. And I had to raise, because of that, I had to also raise the reference frequency because it was overlapping. So I tried that. I didn't get it after 3 days of observations, but we're back. Ted and I are regrouping to see if we can figure out another way to observe it. There is a way to limit most of the problem is that you got so much data across 24 hours, which most of it you don't need if you're just going to observe like M33. So he just showed me a way to just zoom in on that one feature and get only that data so we can start looking it over. That's another thing we're doing. And the third one is my continued exploration on how to do phased arrays. Currently, I've got I'm getting 2 little dishes that I'm going to try to work on. They're on their way, by the way. And I bought some digital phasers. And then I determined that I can't observe the digital phasers because they're above 1 gigahertz. And here's Joe Nambala from Zambia, just walked in. And now, so I've learned how to I bought myself a mixer so I can down convert, and now I'm able to down convert, but then I had to go buy myself an oscilloscope. So I bought a nice oscilloscope, and then I had to go figure out how to do bandpass filters, and then I had to go learn how to do RC networks and use that. So within a couple of weeks, I've now learned more than I have in radio in my entire ham time. That's currently what I'm doing, and I've got a couple antennas coming in that are actually tuned to 1.4 gigahertz. Am I still on? You guys there? Okay.
Yeah, we can hear you, but
yeah, I froze. My picture froze here. Anyway, I'm having a great time doing this, and I think I'm going to have some results from a 2-beam phased array. So these are 2 antennas looking straight up, and as soon as I can get them to observe the galaxy with Easy RA, and I get both of them tied together, then I'm going to put a phaser on one of them. Probably it's the southern one, and start steering, see if I can steer the beam. And then at that point, if I can get the galaxies with Easy RA, then I'm in like Flint. And I can just start adding more antennas and getting more precision and more gain. So that's the plan, and I'm sticking with it. But I've made a lot of, this is the kind of thing where you're constantly breaking things and redoing them, but I'm having a lot of fun doing it. Okay. I'm going to introduce you to Joe Nambala. Joe, are you on? He just came on. Okay, so the other, and he just popped in, and I think he's off now again. Okay, Marcus Fisher, our esteemed vice president, has introduced us to a group of professors at the University of Zambia. And we are talking about putting together a Drake's Lounge Africa. And that's going to be obviously in the closer time zone than the Europe time zone. So you guys might probably want to jump in on that. And we haven't figured out a time or anything, but we're talking about that. And there's a great radio astronomy community in Africa. And as soon as I think it's Joe Nambala comes back on. Oh, I'm sorry, Fred Nambala. Can you hear me?
No, most of you are in the United States. It's 8 p.m. in Zambia. Welcoming us. Yeah, I have network challenges, but I'm with you. Thank you.
All right. We're glad to have you on board. I hope you can see the people show a lot of pictures on this Zoom call, so I hope you can see that where you're at. And welcome to Drake's Lounge for this month. Okay.
And these Zoom calls are provided on our webpage as videos.
That is true. On our YouTube channel too. Yeah. I've sent them a lot of that stuff, and I think they're pretty excited. I've got about five professors that are on our emails that we're trying to get together, and Marcus has pushed a lot of good stuff with this, and so I'm really giving him a lot of the credit for getting the Drake's Lounge Africa online, and we'll get that working. Okay, so let's see what we got here. Let's go with Wolfgang.
Yeah, let's see. I don't think I have very much to report. There was a discussion a couple of days ago about W3, Westerho 3, and the OH mesas there, about the line width and so on. And I did a measurement today with a very high resolution, and I haven't prepared the data yet, but I'll provide that not on the web, in the chat, or not in the chat, in the mail list. That's what the word I was looking for, in the mail list, as a response to the discussion of Eduard and Marcus. The bottom line is, yes, there is a fairly narrow line, but there are several lines from that OH mesa, but it may be worthwhile looking at a high resolution there. Other than that, we're doing, I would say, business as usual, doing FRB observations recently with not much success. They're fairly silent, the ones that we observe. And other than that, our routine observation with OH mesas is ongoing. We just had another round of observation. I think that pretty much covers it. Also did some routine stuff on 22 gigahertz with water mesas recently, just updating of what we had. Maybe it's worthwhile mentioning and saying a few words about the UCARA in the UK that we had recently. Very interesting talks that we see. I understand all the talks have been recorded and will be made available on the internet. So I think it hasn't happened yet, but it's going to happen. It was very well organized by the people in the UK. Thanks again for that. And also it was the UCARA that had the largest attendance with more than 70 people. So that was really a great success for our UK guys, having that number of people on site. We also enjoyed having a talk by Jocelyn Bell about her discovery of the pulsar. It's always amusing and entertaining to listen to her, but also it's scientifically interesting, also, of course, for her historical reasons. The other thing, it's worthwhile looking at the different videos once they come out. I just want to mention one talk which was given by a gentleman from Japan who is now working at the SKA organization in the UK. And he gave a presentation, not about the SKA, he gave a presentation about little antennas that he's making and the outreach that he's doing with children in schools for hydrogen observation is really worthwhile looking at that. He did some very funny antennas, like all sorts of household things to generate a antenna, which is capable of showing the hydrogen line. He has also developed a simple program which works with the RTL-SDR to observe the hydrogen line. I will put that in the mail list, the link to that program. It's a Windows-based, very simple-minded, but maybe that's of use for people who really want to do something quick and dirty. Yeah, I guess that's all I have for the moment. And if there are any questions, I'm happy to respond.
That it? Okay. Thanks, everybody. Or thanks, Wolfgang. Let's go to Eduard, who has just started his YouTube channel up.
Hello, hello. Can you hear me?
Again?
Can you hear me?
Yes.
Great. Okay. Yeah. So I'm currently in Germany. I'm just coming back from a star party, and yeah, for this star party, I brought with me a small antenna, sort of inspired by the work of Asayama Shinichiro from SKA, who gave that presentation that Wolfgang was talking about at the UCARA conference a couple of weeks ago. Yeah, and it was a huge success. So yeah, this little antenna drew a lot of attention and interest from the visitors of the star party. I was the only one there doing radio astronomy, so yeah, I did some demos like showing the hydrogen line and even making a simple map of the sky, which shows the galactic plane. So yeah, that was a huge success. Other than that, not much to tell today.
Well, explain this antenna that you guys talking about.
I can maybe show some pictures. I'll try to share. I'm on my phone right now, so all right. So can you see this?
Yeah.
Okay, great. So this was the little demo by Dr. Asayama at UCARA. You can see his little antenna in the background, made from balloons and aluminum foil. And this was my version, a little bigger. So it's made out of an old milk pan, some cardboard and aluminum foil and aluminum tape to hold it together. It's about, so the horn opening is about 40 centimeters wide. So here's my little setup on the star party. So you can see that I put my antenna in the rocker box of my Dobson. So I can turn it around, point it at different parts of the sky. So yeah, this is just some demo, some plots showing the raw spectrum from my SDR with the hydrogen line as a little pump. So zooming in here, you can still see quite a large, yeah, the background is not flat because of the effects of the SDR, the artifacts of the SDR. So, but that's easy to fix. Just fit a third order polynomial through the parts of the spectrum outside the hydrogen line and subtract that, so get a nice flat spectrum. So this was one of my best attempts at a sky map. So what I did is that I put my antenna in the rocker box of my Dobson telescope, and first I pointed it at 10 degrees and then I turned it around while taking spectra with IF average, and then I put it at 30 degrees and repeated this, and 50 degrees, 70 degrees, and finally just pointing straight up at 90 degrees. So essentially that way covering the entire sky. And then I wrote a simple Python script that takes in all of these spectra, then selects the highest value of the part where the hydrogen line is, and then plots this in a heat map. And then finally, as a final step, I convert this map into polar coordinates so that it's essentially showing a view of the sky. So you can see, I was really surprised that you can, even with such a small antenna, you can still recognize the Milky Way as a bright band. So here's another one, just showing my own plot over a stellarium screenshot. And you can see that, yeah, the bright band pretty much perfectly matches up with the Milky Way. And yeah, here's a final version where I also attempted to show the Doppler shift. So I essentially did the same plot for 3 different channels. So one is between 1420.3 to 1420.4, then another one around 1420.4, and then another one at 1420.5 megahertz. And then plotting these 3 different maps as 3 different colors over each other. So yeah, here you can see the Doppler shift throughout the sky. So of course, this is all not VLSR corrected. It's all quick and dirty. So it's mostly showing, I think, just the motion of the Earth around the sun. But it's still cool, a very cool demo. I think it was very successful. So yeah, that's it. Any questions?
Well, I have a question. Can you put that into a paper or something like that? We can show people how to reproduce what you just did, because I think this would be great for schools and to do this.
Yeah, I can quickly throw something together. No problem.
That'd be great. That'd be great. Excellent. Oh, and also do you have a link to your YouTube channel? I just saw your YouTube video. And is it a channel or is it just one YouTube video you're going to do?
I don't really have much plans yet. Maybe I'll just post some more videos in the coming months. I'll see.
All right. Glad to see that. And I'm glad got people expanding out and getting the radio astronomy really out there. Great job.
Yeah. I got quite a lot of enthusiastic reactions. So even some people asking for instructions how to build their own. So definitely getting somewhere.
Perfect. All right. And during the winter, we're going to get all these optical astronomers shifting over to radio astronomy during the winter for some reason. Okay. Thank you. Good job. Dimitri.
Hello all. Thanks, Rich. Today I have a few slides about 43 gigahertz work. Just a moment. This is work with my new receiver and first version of telescope on mount for astrophotographers, equatorial mount, small dish, 0.6 meters in diameter, good, nice figure of receiver, 1.8 dB, but 43 gigahertz is a bit complicated. A bit complicated band, a bit complicated frequencies, high atmospheric losses, and system temperature includes noise temperature of atmosphere, and for my case, it's about 20 Kelvin from receiver and temperature, and plus atmospheric temperature. And atmospheric temperature depends on the weather and elevation, weather, temperature, pressure, local pressure, and have to be defined every time of observations. as a small forward gain, so system equivalent flux density is order of millions of Jansky. Mount is aligned by alignment by several iterations until correct tracking of sun on the sky. This is photo. The dish is tracking sky, tracking the sun in the sky. At least 1-2 hours of correct tracking is needed for good alignment and then the telescope is ready for observations. First test was 2 weeks ago. The moon eclipse immediately when last observation party was this moon eclipse. I just measured noise from the moon in the deepest eclipse phase. This is about 0.2-0.3 dB to the cold sky noise. And when eclipse is over, the moon noise is 0.5-0.6 dB to the cold sky. I didn't estimate moon temperature for this case because eclipse process need dynamic model of moon heating, time dependent model of moon heating. This is rather complicated. So
Dmitry, we're losing you on bandwidth. Try turning your camera off.
okay. Thank you.
Now we can hear you.
Okay. We'll see how the moon is heated when going out from the eclipse. Next attempt of detections Canis Majoris supergiant star in silicium oxide line 43 gigahertz, accurate frequencies 43.122 gigahertz, vibrational state of molecular vibrational state 1, and rotational transition from 1 to 0 quantum numbers. The star appears very low in Moscow, max elevations about 8 degrees, but as expected, its radiation in silicon oxide is strong and was selected for first major observations in this line. Significant atmospheric continuations and thermal noise from the atmosphere, even for clear weather. Receiver bandwidth about 5 megahertz. Unfortunately, it is difficult to set higher bandwidth of receiver and low resolutions mode, more than 100 kilohertz this is about 1 kilometer per second resolution in velocity units. For this weather of observations, that's about 1 week ago, up to 400 Kelvin system temperature, and up to 7 million of Jansky system equivalent flux density. Integrations 1 hour, and minimal detectable peak flux density about 1000 Jansky. More than 4 dB for such small elevations, 8 degrees. But results and a bit disappointing, at least for this moment, because because offline obtained is very high in Jansky, up to 200,000 Jansky. This is more than 2 orders higher than expected. Flux from peak flux from the star. The line is corrected by atmospheric attenuations to 4.3 dB. Line is corrected, and very high system equivalent flux density. But this line, velocity of this line is about expected 23 kilometer per second. Source is quiet and was used for background corrections in the data post processing, and data about possible. This is data about the star in visual and infrared luminosities, at least up to 10 September. The star is quiet. The star is quiet, and there are no clues about possible flares I found. This is all for now. If some questions, I will be glad.
I have a question.
Okay.
Your picture of your telescope, I know that you were on the roof in Moscow. Yes? I live in a.
This is.
I live
This is.
in a. I'm sorry, go ahead.
This is surely this is Moscow. This is not this is not a roof, but
Yes. Oh, I see. My question is, I live in a large metropolitan area. When you look out, are you in on the outskirts? Are you in the middle of the city? Or do you have to orient a certain way to minimize interference?
in the middle of outer. This is not a center of the city. Interferences can be high, nevertheless, but for 43 gigahertz, I didn't expect any interferences in these frequencies. So gain and amplifications, gain of receiver is rather high to avoid any interferences at intermediate frequencies. And gain is about 60 dB of receiver, so very high levels is obtained from receiver, but at 43 gigahertz I don't expect any interferences even in in the city.
Thank you.
Okay, any questions for Dimitri? Great setup. Good job.
Okay, thank you. Thank you.
Thank you. Let's go, Andrew.
Hi. Nice to speak to everybody, and to hear everybody there. Thank you. Right. So I'm just going to share my screen. Okay, so a couple of things that I wanted to actually put my neck pillow back on. Neck keeps aching. Wanted to share is this is something I'm just trying, and I'm going to just show a couple of pictures and then ask people to comment on it. And I don't mind negative comments, that's fine. So I sort of finished my first mapping exercise, or nearly finished my first mapping exercise with the 1.5 meter solar dish, which has my antenna as its waveguide and one monopole. And so what I'm thinking of doing is replacing it and trying this and see what difference it makes. So here the coax between the two is obviously ideally it would be half a wavelength, 10 centimeters, but it's a bit short for the distance. So it's 1.5 wavelengths, 30 centimeters, bit of coax. So I wondered what the group thought of that. Here's another picture just from the side. But anyone make any comments on whether they think this is going to improve the signal or not?
I've got a little experience with a 2-channel or a 2-polarized pulsar feed. And the difference there is that they actually had a LNA hooked on each polarization, and they combined it with they combined it in GNU Radio. The two data sets were mixed in GNU Radio digitally. I'm not sure what happens when you combine the two polarizations into one signal like you got set there. That's the only, and I just don't know. But my experience is that you always have, it's almost two separate lines until you get to the digital side, and then you combine them. Okay. And that's for pulsars.
Wolfgang and Wend, what do you guys think?
Yeah. I think what you have is a fairly unpredictable situation. So you have your two antennas, which will pick up the two polarizations of the signal. Now, what then happens is that you feed one of the signals into the other feed, which means that essentially the energy received by one of the feeds is going also into the other feed. So you're, in a way, you're radiating it back out. I mean, the starting point would be to look into that arrangement with a network analyzer, which would probably show you a fairly complex behavior. And indeed, as Rich has pointed out, the better way, if you want to improve your signal by picking up the two polarizations, to just have a LNA at each site or at each pickup, and then later on combine the signals, adding the signals after digitization, or use a analog detector on both and add that. That's I think my first assessment. Is going to be very complex to predict what this setup is going to do.
I've got spare kit, so I could easily set it up with an LNA at both and feed down to separate software-defined radios, and I've got a couple of spare mini PCs hanging around so I can collect them separately on two different
Yeah.
computers and then attempt to combine afterwards.
Yeah, what you would expect typically if you have a non-polarized signal like from the hydrogen line, you would see an improve of the signal to noise ratio by a square root of 2. You also have twice the signal. You also have twice the noise, but the noise correlates differently compared to the real signal, so you get an improvement by a square root of 2. Actually, from our 25-meter dish and also on our 2.3-meter dish, we are using dual polarizations and using a scheme where we keep the polarizations separate until we really combine them on the digital level. And that turns out that we exactly get the square root 2 improvement.
Because I know that's what Jason and I have been doing on the 20-meter dish, because that obviously has got two different polarizations, two signals, but we've been averaging them out together to just try and improve the signal to noise ratio. If I understand what we're doing correctly, which I might not be. Is Jason on?
Yeah, I'm here. Yeah, that's
is that what we're doing, Jason, or have I just?
Yeah, that's what we're doing. Definitely. Yep.
I might have said it wrong.
Yeah. It's both polarizations are already in the file, so it just makes sense to use both.
All right.
It's like
so what I'll do here is
signal for free, right? So
yeah. So what I'll do here is I'll remove this this combination, or I could put it in and just try it and see what we get for a couple of days, and then change it over to two separate LNAs and see how that compares. That'd be interesting bit of experiment. Yeah. Okay. Thanks, Wolfgang. Thank you.
Yeah, that'd be fun to see what happens. But I think you're right. It's going to be different.
Yeah. Well, thank you both very much for that advice. That's brilliant. Thank you. What was the other thing I wanted to show you? Okay. Right. You mentioned GNU Radio. So I don't know very much about GNU Radio. So here's GNU Radio on my computer, and here is a GNU Radio GRC file, which is altered from somebody else's, and I've attempted to bring it in to show to the from an RTL SDR blog source. Try it out, and when I run it, I get this, which I don't think is showing anything very much. And if I change it over to easy radio astronomy, I see a little peak. I put it on here, I don't see a peak. So is there anybody who on this group who is good with GNU Radio who would be kind enough to give me a little bit of time on Zoom or Microsoft Teams to help me try and error check my GNU Radio file?
I think that Marcus Leach is the GNU Radio guru here, but he's not on the call now.
Yeah, well, I've asked Marcus, but he said normally he would say yes, but he's extremely busy, so he's not in any position, unfortunately. Oh well, yeah, I'll have to keep searching then. Okay.
Yeah, so I can't help you either because GNU Radio is also still black magic for me.
Andrew, you might touch base with somebody at the Dispara group at the University of West Virginia, because they have specifically a public outreach program that uses some code written in GNU Radio. So and they actually have an outreach team that their whole function is to interface with the public. So that's where I would suggest.
So Andrew, just looking at this thing, it looks like you've got a Fourier transform output, and
I'll pull it back in.
And it's instantaneous. It's an instantaneous output. You're not combining the output, turning it into a magnitude over time. All right. So you basically got an FFT that's just going to go. You need to be able to turn that instantaneous FFT into a total power or a frequency line, and then store that, and then plot that over time, which you don't have currently in your system there. You're basically
so Andy is suffering because of my program here. There is the block integrate over on the right-hand side that combines over time, but I'm having trouble getting results from this too, Andy. So be patient, and we'll try to find a way.
Okay.
Oh, yeah.
I see. There you go.
There's a bit more to it. A bit more to it. Yeah. So sorry, Ted. I didn't want to drag you in, but embarrass you. So apologize.
That's okay. This is what we're trying to get people to see the stuff so we can help you fix it. And
I mean, all I see is lots of lines. Anyway, thanks, and thank you, Ted, for allowing me to try out your script. Anyway, it's as always, I'm very happy to do that, and because if there's anybody who's able to break something, I'm it. I'm really good at breaking things, actually.
You are on the frontier, and sometimes it hurts.
That's right. That's why we want you to break stuff so that we won't have to do it ourselves twice. Okay.
Oh, well, there we are. That's me.
All right. Well, keep going. Let's see. Let me see any more. Okay. Let's go with Jason and Lisa.
Yeah. So so I was kind of ever since I've been in New Mexico, and my portable dish that I brought didn't really stand up to the weather. Back in January, it kind of got damaged by the wind. I've just been kind of too busy to mess with it. I've done a little bit of playing around with other things when I was in the apartment, but now that Lisa and I are in a house and we actually have yard space, and also watching Eduard's video tour of his 3-meter dish, which was excellent, by the way. That kind of inspired me to kind of get going on a new dish design. And so I've been in the design phase using I modified my Excel tool that I used to design my original dish, and I basically made another tab, and I thought, okay, I've already done a 3-meter dish design, a symmetrical center focus. So I thought, why not try to do an offset design? So what I did this last couple days is built a scale model out of corrugated cardboard to kind of test the concept, and this is the result here. So, and just for scale, this is me. So it's roughly the size that I would be. So so I found that the design is, I think, structurally sound. So the idea is to build it out of plywood in sections that could be assembled and disassembled, similar to what Eduard's 3-meter dish is. And my plan is to, instead of using Faraday fabric, to go back to aluminum window screening like Eduard used on his, because I think it'll be it's an excellent reflector at 21 centimeters, but it's also permeable to the wind, so it should make it a little less of a sail. I think this thing looks like an oyster shell. But anyway, I'm planning to build that in the coming weeks and put it through its paces. So stay tuned.
All right. Any questions for Jason, Lisa? All right. Glad to hear that. Let us know how the design goes. Pablo.
All right, get ready for the fireworks. You guys are going to hate me. I've been experimenting with my Discovery dish. I'm getting over COVID now for the past 8 days, so bear with me. And before I got COVID, I fed 1,000 data points from my Discovery dish from my IF. I forget now. From my Discovery dish into Chat GPT and started asking questions and creating graphs. But before I go on, let me share the screen for a second here, because you're going to be interested in this. Where's the share? Is that screen 2? Yeah. So when Eduard or somebody asked the question on a antenna, can two elements using a coax to connect both at the same time to an LNA, both elements 90 degrees apart with the signal be added? Knowing full well that Wolfgang is always right. So I tested Chat GPT, and this is not only, this is the paid Chat GPT 5, this is a chat called Cosmic Gigahertz Decoder that somebody created specifically for radio astronomy, and the answer he came up with was exactly what Wolfgang said. So I wasn't testing Wolfgang because I know he's right. But I was testing because I've been trying to test to see if Chat GPT is actually doing a good job. And in the short answer, if the two antenna elements are placed 90 degrees apart in polarization, one horizontal, one vertical, and you connect both simultaneously to a single LNA via coaxial junction without any phase adjustment or combiner network, the signals will not add constructively. Instead, they will partially cancel or degrade each other, especially for unpolarized or linearly polarized signals, which is exactly what Wolfgang said. And then it goes on to explain why. It goes on to explain how to fix it, and the summary, and how to fix it and everything else. And this is just by that simple question. So what I did then is I added 1,000 data points from my little 70 centimeter antenna, and you can only add 10 on ChatGPT, 10 data points or files at a time. But if you zip it, you can put 1,000 and it will detect everything. And I said, okay, I want you to analyze this and tell me what you found. And it gave me a summary of my little antenna. I said, give me a summary. It said telescope center of scenery pointing direction zenith, data type, radio, blah, 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 blah. Detect 21, blah, 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 blah. Spectral fitting results, triple Gaussian model parameters, component 1, center, 13.7 kilometers per second. This got all from the data that I just fed in there. I don't know if it's accurate or not. That's why I need PhDs to actually look into this, at my data, and look into this. Then it goes to interpret. But the interesting thing, it graphs the spectrum. The average spectrum, the velocity profile, triple Gaussian fit, component 1, component 2, component 3. Then it did individual components with the velocities. This is all from from the IF average. I'm sorry. I'm still getting over it. And I didn't do anything except ask questions. I go, just look into this file. I want you to analyze it, explain it to me. I want you to graph it, make reports. It gave me this one here. Then it gave me a comparison with simplified galactic rotation model. This is the simplified galactic model. Then it gave me H21 light detection with baseline removed. And by the way, that data was not great data. I just plopped it in there. Comparison with a simulated Lab H1 survey. And by the way, if I don't know what it all means, I just ask it. I go, explain it to me in lay terms, because I have no idea what it means.
Sorry,
it created all these
Chat
things.
GTP you're using?
I'm paying $20 a month, and Chat GPT, you can ask for anything. Law, medicine, they have GPTs for everything. This one, somebody created a GPT for radio astronomy.
Oh, so this is all coming out of that GPT for radio
It's all
astronomy.
coming out of that GPT. This is a picture that it created of that little data based on simulation of the... It did it all within 5 minutes by asking simple questions. I got another LNA from the Discovery Dish people, and I'm going to put that on my 1.7 meter antenna, which is about 100 feet behind me. And I'm going to add it to this, and I'm going to have it analyzed. So I don't know if this is accurate or not. That's why I think somebody, or most of us, should do a study, see if we can use this. There was something else that I wanted to show you. Oh, okay. Anyway, galactic. Oh, available downloads. It tells me. It keeps asking me questions. Hey, would you like me to do this? Would you like me to make a movie of the data? I go, yeah, sure. Let's see. Summary. Oh. This is simple stuff. Let's see. What else do I have here? All right. Anyway, so I'm playing with machine learning here. I'm analyzing the data with it. I have no freaking idea if it's accurate or not. However, Wolfgang just gave me a data point because I checked his answer with this and they match. So the Discovery Dish is doing a fantastic job for 70 centimeters. And I'm going to add a little chicken wire trap for noise soon when I feel better. And I'm going to have 3 antennas working simultaneously. And I'm going to add all the data into Chat GPT, see if I can add it and make comparisons, single, 2, 3, if there's any gain, any correlations. So it's totally unscientific, and I'm using the crutch of Chat GPT because I'm not a scientist. So that's what I'm doing.
I have a couple of comments about it, if I can make them. I too am paying the $20 a month fee and using it, and I find it unbelievable. But what we have to remember too is it's not a stable thing. It's growing, it's learning. It's going to continue to get even stronger as time goes on. And it's taking information that people like yourself are feeding into it to help it grow. So stand back. It's going to get even more amazing.
I had a problem with, I have 20 computers, and for my 2 observatories, I have roll-off roof observatories, 2 of them in the back, and I needed one of the Windows 11 computer to connect to a Windows 10 computer with the weather data to make it automated. If it gets cloudy, it'll automatically park the telescope and close the roofs, and there was no way that I could connect. I went to Chat GPT, and I go, in very lay terms, tell me what I'm doing wrong and what I can do. And it gave me there's no way I would have known because it had me go deeply into Windows. I mean, deeply. And I had no idea. Boom, 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 fixed it. It's like having a scientist at my fingertip. Now,
Pablo, I have a question concerning your starting data. You said you entered 1,000 data points. What kind of data points were they?
from the IF average. You know,
From which sky location was it?
Zenith. That's all I did. I just wanted to experiment with Zenith.
Pablo, I didn't get that. Can you say that again, please? You didn't
Zenith,
talk about
90 degrees up, straight up.
Yeah, so essentially, these are the data that you fed in were the spectra from different locations in the sky.
No,
Or,
from the same location in the sky, it was a drift. It just
it was a drift, which means these are different locations in the sky. So the
correct.
sky is moving, and if that is true, then the whole story is, I have to say, complete nonsense. I mean, this ChatGPT is comparing it to a lab spectrum.
No, but it actually looked at one portion. It didn't look at 1,000.
Okay. So when you say you entered 1,000, so which part? So what time frame, or it's really what was this databases that ChatGPT was looking at?
I was looking at just a passage. I just look at the passage of the highest point.
Yeah, so one part. So it was still looking at different parts of the sky, and it was comparing it to a lab spectrum, not knowing what the spatial resolution was, not knowing what the position was. So this is pure guesswork. Then it identifies lines which are simply the curvature of your baseband lying out at 170 kilometers per hour. Nothing is going to happen at 170 kilometers per hour in our galaxy. So it is just, from a brief look at it, it's just dreaming up things. It's has nothing to do with your data. It's just a story dreamed together.
Or it's, which is absolutely possibly true. Or it could be that the prompts that I gave it, because I don't know what the hell I'm doing, and I didn't give it the correct prompts to say, I want you to look at the data from certain time to this time, and this is what. So it depends. Yeah. It's prompt dependent. So you as a scientist, you can put the prompts in there and say, okay, I want you to analyze this data from this to this. This is what happened during that time, blah, 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 blah. You put the prompts. And it'll say, okay, based on what you just gave me. But
then the criticism that I have is you throw in a number of data, and what ChatGPT, that's a big deficiency. What it does not do, say, sorry, I can't answer your questions based on the data that you gave me.
No, sometimes it does.
Just goes ahead and dreams something. We've seen that many times. So if there are things where there's a good learning base behind it, the example that you have given, these are fairly defined questions. In this case, you're giving a data set. You just throw in. You have not told ChatGPT what sky position you were looking at.
But it's my failure. That's what I'm trying to tell you.
But it's
if you enter your data, just like you enter your data on a computer or you enter your data on a calculator, the difference is that you know what the heck you're doing and I don't. So in your case, you can enter the data and explain through prompts exactly what the data is from, and you as a scientist, you can ask it, okay, I want this based on that. So it's nothing more than a supercomputer working on your behalf based on your knowledgeable inputs, which I don't have.
But that's exactly the problem that you have. ChatGPT dreams up an answer. It gets some kind of input. Then it's
we don't know that because we haven't analyzed my data, and we haven't analyzed. You're just also guessing.
Let's stop it there. It's I have to tell you that the answers that you got in this case from ChatGPT are. I like to cite the word "not even wrong."
Okay, that's okay. I don't take it personally.
So Pablo, so I think is the garbage in, garbage out is the typical term for that. But the garbage in is telling it enough information to do the analysis. So try this. Tell it all the information about your current location, your lat long, start times, your elevation you're looking at, and have it plot the total power from your data.
Exactly. So we got to come up with
prompts
that are input. This was a simple test that I did
Yeah.
to see what it could do, even if it dreams it. But if you put the right prompts, the right information, if you ask for the right information, maybe it will come up with the right answers.
I think a good test of this would be to go use the where the EZRA works and what it's analyzing for the data to get the pictures it's getting, and ask the same questions, and that'll be your check. So the data that EZRA is pulling, the same data, and then it's coming up with these pictures. You should be able to check that against ChatGPT until you get the questions right on ChatGPT, so they can properly analyze and give you the same feedback. Because I agree, it just gave you a spectrum and a certain frequency but based on a drift scan, that's not correct for what you were after, I think. But
I think it's even missing a simple sanity check. For example, it gives you column densities, if I recall correctly, from a graph of 2 per cubic centimeter. That's about 20 orders of magnitude off.
Yeah. So yeah, it's just that. Yeah, I think what we could do is let's work on stuff we can feed Pablo that would feed ChatGPT until we get ChatGPT to come up with the right answer for the data. And then it'd be good. Then they can use that from then on. Go ahead.
Well, if it's a dynamic GPT, if they've turned it dynamic and not frozen the training, it's trained itself on Ezra already. And what will happen is, if you put in the right questions to Ezra, it will give you the result from Ezra, which you could do yourself and make sure that you have it right. I'm pretty sure this will happen if it specifically has some kind of strange LL large language branch for radio astronomy, because I suspect, and I have not been able to prove this one way or another yet, the GPT will not be training on any scientific information that is behind paywalls. It's not going to get papers or results or analyses that are locked away by anybody for money. I'm not sure that this is true or not, and I'm trying to find out. But if it as a large language model, in some sense, unless the training is past now that, which it could be, I don't know, it's moving so fast, it's really hard to tell. But if it has picked up Ezra and you put in the data to Ezra as if you were going to chat, as if you were going to put it to Ezra, it will give you Ezra's answers.
That might be a good experiment, asking it to use.
That would indeed be a serious experiment, and one that I suspect we might want to run, not right away, but perhaps in 6 months or a year. Go ahead, Edward. Yes, go.
Oh, sorry, I interrupted you. Go ahead.
No, I have nothing further on that except except what I suspect, and I do not state this as fact. It's simply something I suspect, and I think that's what might happen, because I don't. Considering that chat is a large language model, which seriously depends on its training, on the availability of the training data, and so on, algorithms or whatever it is they're going to use. And
well, there are ways that one can actually train a GPT. I created a GPT for Astro Image J for detection of exoplanets. Yes, so you can put the data in there, and
Yes.
and basically you put
That's
the prompts, you ask what you want, and
but
it's
you see, Pablo, that's what I'm trying to say. That if it has trained itself on Ezra, you're going to get Ezra.
I don't think it's trained itself on Ezra yet. So
I wouldn't put it. I wouldn't be surprised that it hasn't. I'm serious. No, I'm quite serious on this. I don't think you understand the resources that are being put into the large language models. It's absolutely, it's totally mind-boggling.
It's being used for everything in astronomy right now. Okay,
yes,
even down to the amateur level, for detection of exoplanets, detections of everything. All I'm saying, all I'm proposing here is to have a study, because the cat's out of the bag. I mean, it's, it's being used everywhere.
So, can I add one more thing
go ahead,
to this discussion, if that's okay? So I think this is a really great example, what you just showed, for one reason, actually, and that is how this can easily go wrong. Because I think as an amateur, and even like if you are more knowledgeable about the subjects that you're working with, it's very easy to feed things into ChatGPT or another large language model, and you get stuff out, and it looks very impressive. But how do you know if it's right? And yeah, I think it's very easy to end up in a position where you you're no longer understanding what you're actually doing.
That's why I was proposing that we have to study this, and we have to validate it. Just like the space program, 9 out of 10 rockets crashed, but they kept going. Of course it's wrong. Of course things are going to be wrong. But I mean, this is growing. This
so Pablo, let's take it a different approach for Sarah and using yours, is that if we get some known data with known results, and we train ChatGPT on those known data, known results, known questions asked with known data, and we got it working, then we can promulgate that as this is ChatGPT, because we trained it, is good for this kind of data.
Exactly.
Okay, so let's do it that way. Because right now you sent a bunch of data in, and it came out with some results which
my caveat,
we haven't trained it yet.
Yeah, my caveat was, I don't know if it's right or it's wrong. All I know is that something came out. I didn't postulate that it was right. I said, hey, this has got potential. That
I think I 100% agree. And what I'd like to do is, how would we give you, for example, everybody's here doing experiments, like the guys doing extragalactic and various other things. They've got data, they've shown results that we're all sort of agreeing that those look correct. If we have those guys send you the exact details on how they did it with and the data, and we stick that, and we try to train ChatGPT on that particular, like, how do you set up a maser? How do you do an extragalactic? And we train that.
Correct.
We use that data to train it. And then when we send out new data, then hopefully ChatGPT comes out with the right answers more often, because it's been trained, and then it just gets better after that. Would that work?
I think so. That's double-blind testing. It's just a scientific method.
So would you want some people like to send you some that approach? Let's just do straight hydrogen and how you.
By the way, we can all do it with our own machine language. But yeah, I of course, yeah, I want to find out if it's valid or not.
Oh, I'm going the opposite direction. I'm going to assume it's not valid until we've trained it and verified it, and then we can start considering it more valid after the fact. All right, how's that for an approach? And because otherwise we sit there looking at data that we don't know where it came from, and because it's so complicated.
Also, there are ways to create GPTs, and you can create a Sarah GPT where you can start training that, and for the data.
I like that. That's a great approach.
I'd
Okay.
like to go back and make a comment about the Cantana or the CAN receiver with the two things at 90 degrees also. And that is that when you're looking at waves coming from space, they can be linearly polarized or horizontally polarized, or they could be circularly polarized, left or right hand. And you don't know what you have coming in. So therefore, I think it's an advantage to look at the two probes individually with your two different SDRs. Then you can sort out in your computer algorithm what kind of a waveform you do have, or to get the maximum information out of that wave. You have to be careful, though, to balance the two receivers so that they're roughly equal. And also, it would be best to clock them from the same clock source so that you know you're not losing phase granularity due to clock variation. But it would also be possible to put a delay line and connect those two ports if you know what you're doing, and add those two signals constructively. And people have done that in the past for like satellite communication, for instance, but they knew what the antenna was doing on the other end. And in our case, we don't always know what the waveform is coming in. And so I just wanted to interject that.
Okay, so if anybody has, I'm going to sort of wrap this up, but Pablo, I love this ChatGPT work. I think this is.
And by the way, let me just say one more thing, because I just put, is AI being used in radio astronomy? It came up with 2 pages. Right now, AI is being used in radio astronomy.
Yeah.
Convolutional neural networks and other machine learning models are used for identify radio galaxies, pulsars, quasars, separate real sources from radio frequency interference, classify morphology of extended sources. Example, the LOFAR survey uses deep learning for detecting and labeling complex radio structures in the low frequency sky. FRB detections being used right now. I mean, it's got 2 pages. I'm not going to read all of that. It's just,
be careful.
The Sarah guide we need. The Sarah guide we need is what questions do you need to ask it, and what data you need to get the right answer. Yeah.
Yeah. But,
can I just say something real quick? After Edward.
Go, Wendy.
Pablo, I thought it was you were talking about troubleshooting Windows 10 and Windows 11 so that your computers would work together.
Yes.
This is the first time in my life I have ever heard of a troubleshooting thing of that nature with Windows that actually worked. And to have it work so quickly, oh my gosh.
Oh, yeah.
And also Bob was saying that this thing is growing by leaps and bounds.
Absolutely.
And so,
it helped me yesterday to do something there's no way I would have known to do, because it had me go deep into DOS. And I did it in less than 5 minutes, something that puzzled me for weeks. In 5 minutes.
So this thing is growing. I wonder how long it will take before it's.
I don't want to take up.
I hope we can do our study fast enough to get there. That's all I'm saying.
Okay, I've already taken enough time of your time, guys. But in the future, if you want me to do a whole hour presentation, I mean, I actually voice communication with ChatGPT, and what you can do with it, it'll blow your minds. I mean, it's like the new printing press compared to Google. Google is obsolete, and yes, it makes mistakes and it hallucinates, and yes, but it's right most of the time, and it's getting better. That's all I'm saying.
Pablo, I'll take you up on your offer. When you're ready to do that, we'll do a full hour and we'll post it on our YouTube
I can create
channel.
a presentation. I can create a 2-hour presentation in 30 seconds with ChatGPT. No problem.
I know that's cheating, but my students, I'd hate my students to do that, but you're good to go. Let me know when you're ready.
I'm an old guy.
And we'll set it up. Thank you. Good job. Don Latham, since you were on, see if you got anything else.
Nothing new to add. I did find, excuse me, I did find some on AliExpress. Now that China with trade with China is up and down and up and down, but there are some 15-bit encoders in the $40 range. They're 15-bit absolute encoders, which means that you can get 1/10 of a degree and throw the rest away, but it's an absolute encoder. You have to learn something called Modbus, which is very, very simple and actually a quite nice way to hook things together. And that's what I'm in the throes of doing now.
I'm just going to call Pablo to learn how to run that with ChatGPT. So,
oh yeah,
design the circuit for me.
You can run you can run the circuit and you can design the Modbus code, but you better check it out to make sure that it doesn't drive your antenna into the ground.
You can take a picture. You can take a picture of your circuit and feed it into just a picture, and it'll say, "This is what you got to do. This is wrong. You got to put this."
I know,
just
Pablo,
a picture.
I know it. It'll compare your circuit diagram to existing diagrams. The thing is that it's a large language model. The models you're talking about that they're using for things like LOFAR and so on are using they're using the structure, they're using the analysis tools, but it is not part of a large language general purpose model. It's a specific problem model that's set up to handle that data. And as such, it's using the so-called machine learning which is tailor-made to handle that data, learn from it, and use it in analysis. It's nothing more than a handful of graduate students do. That's it. And if you try to apply it on general ChatGPT, that's always where the nonsense can creep in, because I'll quit at this point. I don't want to go.
That's okay. Dr. Latham has had lots of graduate students that he fed data to, and they came out the same way, right?
I certainly hope so. That's how you get generated papers.
All right, I'm going to keep going. Dennis Farr.
Yes, sir.
Just checking in.
Lurking. I'm just lurking. So glad to have been live long enough to see this happening. I just keep waiting for somebody to say, and forgive this sad joke, but I'm just waiting for somebody to say the answer is 42. If that doesn't make you laugh, then
absolutely, there's no question about it. And I'll be sure to take my towel with me.
Yeah, but are you going to wait for 7.5 million years?
No, I'll just breed more mice.
I'm more worried about Skynet than answer 42. So, okay. Thanks, Dennis. And by the way, Dennis has taken on temporary treasurer position for Sarah. Tom's going through some procedures. So if you got any treasury stuff, Dennis will be doing that temporarily. So appreciate all Dennis's work on that. Chet Mitchell. Nope. Chet, you there?
Chet's on mute.
You're on mute, Chet. Okay. Still on mute. All right. Well, we'll go. I'll get you.
I think I got
there you go.
it.
You got it.
Okay. Yeah, I have a couple of things that I wanted to share. That was getting mute turned off. It was kind of terrifying. Now I want to see if I can share my screen. Let's see. To do that, do I go down at the bottom?
Yeah, bottom center. It should be a share screen.
Got it. Okay. All right, and take the entire screen. Share. Okay. Yeah, I just have some photos I want to share here. I've been doing some work this last month, and I finished a new radio telescope. I call it R2D2. It looks kind of like that. I wanted to build something that was weatherproof, and I found a plan online at Despera for this particular telescope. It's made of a bucket, a piece of a heating duct, and a peanut butter jar. So let me show you the things here. That's the one side. This is the back. You can see how the duct is just kind of duct taped to the bucket. And one of the things that they insist on is that you wrap all your cables in metal foil to reduce noise. Here's a picture of where the antenna goes in, and if you can see, I've got my my sawbird there. So it's sitting basically in a little Faraday cage made of a peanut butter jar. And my plan for this thing is I'm going to mount it on the roof of my garage pointing south, and then just, I'll climb up there once a week and move it a little bit and just keep doing drift scans. I got the wiring upgraded in my garage so I can hook up a computer in there. And so that's kind of what I was planning to do with that. And I'll let you guys know how that goes. I've been so impressed seeing these 10-meter dishes and 3-meter dishes. I'm gonna take on the universe with a 14-inch dish. So we'll see how that works out. Here's my question about Ezra. I have an Air Spy, so I didn't use Ezra for a long time, but Ted's got it working now for Air Spy. And here's my question. On the display in this area kind of over to the left here, you have your master graph, okay? And I was used to seeing that in antenna temperature because I use the Despera stuff, and now this is in decibels. So here's my question. When I look at screen caps that other people have taken of Ezra, and I look at this main graph thing, and I look at the scales, most of them have a scale on the left that goes like from 1 to maybe -5 or something like that. Okay. All of mine go from like -30 to -50. And that fact in itself doesn't really bother me. I mean, it means that I've got a really, really quiet signal, I guess, that I'm working on. But I was curious if any of you have ever noticed that on your systems and whether you see numbers similar to that when you use Ezra. So that's my question.
So I've been using Ezra quite a bit lately. Mine's all in positive though, and I've got a 3-meter dish. The next question is, what does your reference signal look like? So it's really the comparison between your main antenna signal and your reference signal, which is a slightly different frequency.
Gotcha.
That's the difference you're looking at.
Okay. Yeah, and given that I don't have a reference signal, I guess I'm gonna see numbers that are gonna be pretty low.
Well, no, Ezra will automatically it does 1420, then it does 1423. And if you look on your screen on the right, you'll see R instead of blank when you see the signal. So it's actually every other sample is your reference signal.
Gotcha. Okay.
And looking at yours, this is your primary signal, your base antenna signal. And if you watch it a little longer, it'll go to reference. The whole thing will change.
Okay.
And the thought there is that the reference signal is not hydrogen based at all, but it's looking at the same part of the sky at the same time. And so it can give you a non-hydrogen based comparison, and then it subtracts the two, and then it basically figures out what the actual, it's trying to give you a relative thing. This looks like you got a good hydrogen peak here.
Yeah, yeah. One of the things I did this week was I bought a little general purpose amplifier from Amazon for about $14, and little Chinese thing. I hooked it up, and it seemed like it really made a difference when I hooked it up, as opposed to just having the LNA. So, okay.
You just got to be careful of that, because the if your LNA has been fed by your antenna, has antenna bias power, you got to be careful. You don't, those ones you plug in, may not expect 12 volts coming up the line.
Okay, yeah. So it might like take away some of the electricity that it might be expecting to get.
I don't know. It just has 12 volts going into something that doesn't want 12 volts. So I don't know.
Okay.
There is a way to turn that off. Ted showed me a way to turn it off on an RTL SDR, but I don't know about the one you've got. Anyway, this looks really good. I wouldn't worry about that. Just watch the reference signal and see what it looks like. The whole pattern looks like.
Okay.
Well, you can also toggle over in the upper right of that main Ether screen. You can toggle on a mode where it will show you. Where is it? You can do ref div.
Okay.
And what it'll do is instead of just showing you one and the other alternating, it'll just show you the comparison of the two. So the graph will actually show you a corrected plot, basically.
Okay, that's a good idea. I'll try that out. Okay, well, thank you very much for your input.
Good work. We want to see the results of this after a couple sessions. This is
definitely.
Is that the zero spike?
I'm sorry?
Is that the zero spike?
That was 1420 0.4 or whatever. Something like that. It was actually, that was signal, and I was actually expecting it to have a couple little bumps on the side because of where I was pointing in the sky, and I didn't really see that. But that's what that was. Okay. Thank you.
Thank you. Okay, Rick from D says.
Here we are. Hello. So I too am working with EZRA on a drift scan project, and I was down at Haswell Friday changing out some more hardware, trying to get the optimum gain blocks and other hardware pieces. Eventually, I'm going to try to produce 2 different data sets simultaneously for different purposes, different analyses, one of which is EZRA format, because right now I'm using an AirSpy Duo, which has 2 inputs, so I just put a 3 dB splitter and gave both inputs the same signal, but that way I can take and merge the two data collection processes I have and get 2 different data sets that represent the same data but for different kinds of analyses. That ought to be interesting. I may swap out the receiver with a B210 later, but right now I'm just trying to get the basics working. I just sent Ted another data file from the last 24-hour period and let him take a look at it. I analyzed it, and it looks to me like the data levels or the levels I'm feeding it are too high for EZRA, but they're not. Well, I need to talk to Ted about it. It's a complicated matter of trying to get the most bits I can out of the D to A in the AirSpy without saturating the software, which doesn't seem to be very happy about my feeding larger signals in, even though they're in the middle of the dynamic range of the receiver. So I'm still working out the basics, and I may have to put it on hold for a few weeks because we have a open house this Saturday in Haswell. And so they're going to be switching the feed out to an EME feed so they can demonstrate EME communications to the various visitors we'll have. And then there's a couple of EME contests coming up, and I'm not sure if I can put the science feed back in between the contests or not. I'm hoping I can, because I'm really making some good progress on that. And I want to get it to the point where we can start collecting and distributing, making available to anyone who wants to analyze it, the various data sets that we're collecting once we're convinced that they're actually interesting and useful. I plan to make all the data sets public in near real time. I haven't figured out where to put them yet. Right now, I'm putting them in my own personal shared Dropbox because they're just a little too big to email around, but they're much smaller than data sets I was collecting a month ago. So we're making slow but real progress.
Okay, great. And I think it's the EME Earth Moon Earth or Moon Bounce is a 1240 megahertz transmit feed, and that's why you can't use it for 1420 receive only. We got a transmitter on it.
No, that's not why. There are signals out there that are interesting and useful at 1296, but
96.
the design of the feed that Alex has produced puts all the electronics in the feed and brings the signal down on Ethernet. So we have voice and CW and all that stuff, but he doesn't give me the RF to feed into my space science receivers, so I'm cut off. And I'm still trying to negotiate that design setup with Alex, because he's 100% on these various projects, including deep space at 8 gigahertz, where he puts everything in the feed. But that means when that's active, I've got no signals going into my science SDRs.
Got it.
Say hello to Homer. He apparently is either hungry or wants me to take him for a walk because he's eating my thumb.
All right.
I have a quick question. You mentioned you're using an AirSpy with a dual input, or is that an SDR Play Duo that you're using?
I'm sorry. You're right. I keep mixing up the names.
Oh, I do that all the time. Yeah. Okay. I just wanted to make sure because I've got an SDR Play Duo, and or whatever they call it, and I'd like to use that for radio astronomy. But it seems like at least some reports seem to say that it's somewhat deaf in terms of listening at around 1420 or so. So I was just curious if you had observed anything like that.
Well, that's why I'm playing around with external gain blocks. We have, of course, a very good low noise preamp in the antenna, but then when we get it down into the lab, I'm using an additional amplifier for that's designed for that frequency, and I'm trying to figure out how much additional gain I need to give the SDR a chance to produce good results. Now that SDR also has a switchable RF stage and a switchable passive attenuator. And so you can turn the RF stage on and off, and the attenuator can be selected in a variety of selections. But all that said, when the SDR is set to the highest gain setting with no attenuation in the RF gain on, I need additional amplification, not to make the noise figure better, just to push the noise up into a reasonable level, so the SDR's A to D is got enough signal to resolve more than just a few bits. So yeah, you're right. I think it's a little deaf. It needs more external gain than I was hoping it would. And if I can't sort this out, I'm gonna switch it out for a B210, which I know that's a whole lot more expensive piece of hardware, but it also has 2 inputs, and I'm pretty sure I know how to use one of those.
Do you think that using the Sauber H1 LNAs in the inputs for the Duo, do you think that would provide sufficient gain to compensate for its sort of somewhat lower ability to amplify?
I'm using Chinese gain blocks, which seem to have decent noise figures and gain, and are available for, I don't know, $20 each in 10, 20, 30, and 40 dB variants. And then I have attenuators if I need to fine tune it, but I shouldn't need to fine tune it more than that. And right now I'm using a 10 dB gain block right in front of the 3 dB attenuator. So I'm making up for the 3 dB plus 7, and that seemed to put the SDR into a good range, but then when I'm running the collection software, it seems to be saturating the software. The software doesn't seem to be tolerant of a variety of input levels, even though they're not. I have a signal generator that I also feed up into the antenna, an HP signal generator, and I can feed a carrier back in through the front end of the antenna all the way back through the system, and I can actually tell how close I am to saturating the A to D converters by using that signal. So I know that I'm still in the linear range of the front end of the SDR, but it seems to be saturating the software, and you got to have a chat with Ted about that.
I see.
Right,
okay, great. Thank you very much.
Thanks. And Adrian, by the way, he's talking about a dish, a 60-foot dish. that is almost 200 feet away from the SDR.
Oh yeah, I'm actually a member of the SES also, so I'm familiar with what he's working with.
Oh,
At least
okay.
not personally. I've yet to make it down to Houseville, but at least online stuff.
That's good.
But
Well,
I'm kind
now
of
I got
familiar
you.
with. Yeah, go ahead.
Now I got you on. Why don't you go ahead? You got anything to say? You got any input for the group?
No, I've been sort of under the weather for the last couple of weeks. I've got kind of like an inner ear infection that's got my balance and everything just sort of messed up. But I'm kind of tinkering with some hardware stuff. But
Okay.
yeah, I'm somewhat familiar with those little Chinese amp blocks. I actually use those at home for homemade TV antenna where the signal's kind of weak and it really makes a big difference. So I know that they work pretty well. But yeah, I'm curious because I'm really trying to see if I could utilize the SDR Play Duo or system for radio astronomy because of that dual input and the synchronized receivers. I think that would be useful in light of a lot of the conversation today and interest in the orthogonal monopole cantenna sort of arrangement and applying it to that application. So it seems to be a lot of interest in the design of that. I've been really looking at that now for quite some time for attempting to use that again in conjunction with the Duo, and so it's been very sort of instructional for all the comments on it, expertise regarding the two monopoles at 90 degrees in that antenna, cantenna. But no, that's all I've got there. Thanks.
Hey, thanks. David Kunzman.
Hello, just slowly putting together the Inspire kit for the natural VLF, low frequency radio waves. And then since I don't have a lot of space, just slowly going through the CASA tutorials for data reduction. And then another question, once one goes to the tutorials, what's like the, I won't say the next step, but what can one do with that after? Just pick a data set and just reduce the data?
Boy, I'm not sure. I think there's a national group that collects all the data. So let's see. Did they give you an email address on that? Who to contact? Did I lose you?
I'm not sure. I've just been going through tutorials and just wondering what one can do after that with CASA.
Yeah, you're monitoring the sun, I think, on the Inspire. And I think there's a group that actually.
Sorry, Rich, it's Andrew here. Is this the same as the old Inspire, which I've got? It's going to be mostly lightning.
Okay, so anybody collect all that data there, Andrew?
Well, my problem is it's a demonstration device. At least the one I've got is really a demonstration device, unless they've changed it. I have had it for a number of years though, and my problem is it picks up 50 hertz hum from mains from miles away. I mean, literally, we tried to go out into the countryside with it, my son and I. Plenty of lightning crackling away, but we could pick up the electrified railway a couple of miles away.
Whitman Reeve, R-E-V-E, I think runs the Inspire program or is involved in that. And they recommend you, and he listens in on the listserv. So I'd say ask your question on the listserv and see who would respond that's actually using this.
Yeah, I know you can record the data using a tape recorder, and I think that's what, if you go on the website, that's what they say, and then you can send your tape in to whoever collects the data. But my question was for the CASA tutorials, for the VLA and the ALMA stuff, the stuff that you put videos up on.
Right.
Yeah, once I get done with the tutorials, like
Oh, I
what are the
see. Yeah.
what are the possibilities for data reduction
Oh,
on those
okay.
data sets?
Well, when I was doing that, I was really excited about being able to take the historic data from all the different big antenna dishes, big antennas, and be able to reproduce the pictures of the sky with the different frequencies, and learn all the calibration and learn all the stuff with the CASA. What do you do with it? If you were doing science, you might be able to get some science out of it. And you can also look at the articles that people actually use those, what the science is, because that's in the database. You can, and then you can try to reproduce that. If you're not used to doing science with it, then make it your art gallery, I guess. Just like a lot of this stuff is just to prove you can do it, and just the learning curve of what you're learning it. I think just doing it, you'll learn so much about radio astronomy just by having to do the whole CASA tutorial and producing those things.
Yeah, by the ones that I've done, I've learned a lot, so that's been helpful.
Yeah, that's what I did. I mean, basically, you need a little more data to do the science and a lot of time to do the science. I mean, if you're going to try to discover something with this data, that's a lot of deep diving into that stuff. So either way, it's fun. Okay, let's Tom.
Yeah, I'm here, but I'm not going to turn the camera on because I don't want to scare people. I'm not exactly the Frankenstein monster, but yeah, you can see marks and stuff and bruises underneath the shirt. But I'm here and I'm having I'm in between. I've done stuff this week. I do stuff next week, and we'll just have to wait and see how I feel at the end of all this.
I just understand the UTC -4 thing. Is that
Yeah, I don't know
like
whether that's helpful to people, but that's my time zone, and I guess when we go back to the standard time, I'll have to make that UTC -5. But
okay.
but yeah, I don't know whether that'll be helpful to people to be able to see there where people are located. But that's one of the things that I put in my SIG files, is to actually say where I'm located, because that's something that people can't tell.
Okay.
And I don't know, one of the other things would be to use a Maidenhead grid locator or something like that. But yeah, I added that today because I thought maybe that would be useful for people to have an idea about where I am located.
Yeah. Well, we're getting a lot of people from different countries on now, so maybe that'd be useful. All right. Thanks, Tom. Stay in touch. Keep better. Bob, your name was used in vain today because Tom Crowley has a grant request for a muon detector. And I threw him your name. They're looking for a good muon detector, and I think Tom Crowley is actually going to buy one from a university to try it out. So I thought, so your turn. What, you got anything going on?
I don't have anything really to report today. I am still working on my muon stuff, but I've been pushed off of that for about almost a month now because of other domestic things. But I would say maybe the UK group was going to be selling them. I'm not sure where that stands. Andrew probably has more information than I do on that. But if they're selling them, I think they were reasonably priced, and that might be an option for one. They're, I think, $200 or $300 range roughly.
The UKRAA's, UK Radio Astronomy Association's Pico muon detector is probably the best value one available now. It's actually a step up from the Cosmic Watch design, and actually is equivalent of 2 Cosmic Watch detectors in the same housing.
Okay, I may hook up Tom Crowley with you guys or with you, Andrew, to see if he can.
Yeah, sure.
Do
No
that.
problem.
He's okay.
I put one so we could see it in action if you want.
Okay. Let's see. Anybody else? Helen, did I get you? And maybe not. Okay. Professor Nambala, can you go over a little bit what's going on in Zambia, University of Zambia, and with radio astronomy? And
hello, I'm still with you. What's the question again?
You're sort of our last talker here, and I was wondering if you can give people a little idea of what the radio astronomy community in Zambia is doing.
Zambia.
Well,
okay,
I mean,
so basically, yeah. So basically, we have a course in the physics department offered at 4th year level in astronomy and kind of astrophysics. Then we also have another course in space physics, also at 4th year level. But we haven't done much because this is our 2nd year of teaching those courses at the university. So we are still building capacity. And so we will be happy to learn a lot from others, especially regarding experimentation, because we don't have so many things at the moment. So this is basically when we are sort of organizing ourselves to put up things together. But a number of faculty have trained in astronomy. I was personally trained at University of Cape Town in South Africa. My colleague was at Hartrau, that's Hartrebuzuk Radio Observatory in South Africa, somewhere near Pretoria, Johannesburg. So a few of us are coming up, but we are still a long way to go. Hopefully, maybe by next year, we'll have started doing lots of practical experiments. But for now, we've been doing too much of theory work. So that's about all from my side.
okay. All right. Well, we'll see if we can get help out the Zambia your group in radio astronomy inputs. Thanks for coming on. That's all I've got for Drake's Lounge this week, and next week is Drake's Lounge Australia. I was sending out a notice on that. All right. Thank you, everybody.
Sure. Thank you. You are most welcome, and we'll do our best to keep joining the conversation.
Yep, absolutely.